Hello viewers, welcome once again to my new screencast. Today I will present and demonstrate a new screencast number 28. In this screenshot I will focus on on the on the on the breaking the one monolithic application to the microservice applications. In the previous screenshot I already discussed about how our Grails and Groovy based web applications, this application was a little bit monolithic. We tried to modularize these applications. This is the 27th of screencast, and it was the Groovy Grail based, and this application had almost 42 domain classes or domain objects, and it's a little bit monolithic, and this application had basically 4 parts. That means as a city planner or city engineers, they have the different department, like the plot management department and building management department and floor management department and unit management department. And that's why they are asking me to break this application and put it for specific modules for these applications. That means is a little bit monolithic application. We try to put them as a microservice applications, and that's why we are trying to break this application and put it to some microservices or Microsoft API. Then later they can start the web developments, and that's why we try to make a new screencast for 28. And this application was a backend server was Postgres and MySQL, and there's another version was NoSQL based MongoDB server. So please, the application name is look like Urban Development and Control Management Systems. I did the screencast 27th. Please go there and watch in detail what is there. So this is our 28 screenshot, and this is screencast, and this will be the solution for non-SQL based, and I try to illustrate here the Elastic based microservice or RESTful API development and testing and external configuration and deployments. The external means for this case we use Spring Boot profiling concepts. So that means when your development is done in development environments, and you did your test in development, and you configure your application and deploy to application into different environments. So that means you need your backend server for migrate from dev to test to QA to productions, and then you need your application to integrate or to configure or to deploy your jar into the different environments. And after that, the web developer can call it and integrate their web framework or web, whatever it is GSP or JSP or a simple HTML or JavaScript. They can call it and communicate it, because it's a HTTP protocol based RESTful web services. And this is the diagrams to explain how the backend developer and the web developer communicate each of them among them. And if you are in the small company, then you will be responsible for the whole development stack. I mean the full stack developer. So you have to develop your back services, you have to prepare your backend, and then you have to integrate your services to the front end developer. So a lot of viewers and subscriber notice me, then they need some theoretical background how the web service and web API is a theoretical background. So I did the study, and I try to explain a little bit here how the technology works and how the processes works, was the background, the abstract background, was the protocol we are using, and was the next is coming soon. And that's why so the service oriented architecture is a very it's an abstract design pattern. That's design pattern to communicate the service to services and applications to application through protocols. So we have 2 protocols. We have SOAP protocol SOAP protocols and then the HTTP protocols. So SOAP protocols means it's a communication via the XML, and HTTP protocols like the RESTful, and its communication will be done by as a format by XML or JSON or plain text, or there's a lot of formats for with that one. So they see so SOA is started and is a SOA as a web service as a technology of SOA. Or we can say the web service and the web APIs are a technology and concept of SOA. So I will put the next screencast about detail what's the difference and what's the application, how can we categorize or how can you segregate or differentiate between web services and web APIs. And I will make a new screencast with that one based on that one. So you see that there's a lot of APIs, and very beginning Java web service development APIs, and the beginning it was the Axis 2 and 1 and 2, and then after that after a couple of, it was the very beginning of 2010, 7 and 10, I think so. Axis is popular nowadays, part of JAX WS2 popular, and the two technology is based on the SOAP protocol. That means, and you say you have two implementation, RPC style implementation and document style implementation. You see this is the format of the message or for communications. And then this is the JAX RS. This is the most latest technology nowadays. Every developer or every companies or every projects they are trying to put it really JAX based, JAX RS based web services or web APIs. It's REST web, and this has two implementation, and REST easy and Xerxes. And this is that you see there's a lot of format to the communication. So XML, JSON, text, HTML, and so on and so forth. So that's the most popular one. So for us, we have a lot of implementation for the SOAP and the JAX RS. For this, the customer, and they're asking me to provide them the microservices, web services for to breaking this monolithic application to the microservice application as a REST services. That means, and for that case, we use the Spring REST services. Now is a question: when should we use the REST RS and Spring REST? This is the big questions, and the client asking us, okay, it's our decisions, but we did our discussions, we did our research, and then we find out that okay, JAX RS is a little bit older if you are really in Java based, and then if you are in the Spring in platform, or you use the day-to-day Spring, then it's better way to use or to integrate or to use the REST Spring REST service, REST technology or concept of the implementation of RESTful API or RESTful web services. So you see the difference between the Spring annotations and JAX RS annotations is simply the annotated difference, but in Spring is the most popular and most effective to implement, and there is a specific implementation and a specific advantage or benefit for over the JAX RS. But in the Spring REST, in behind the scene, they are using the JAX RS protocol over specifications. That's the idea of the Spring extension. So for our implementation, we use the REST Spring REST concept by Spring REST technology. So here is our just like theoretical idea, the Spring data and Spring REST. You see the SQL based databases like JPA. So then you see the Postgres here, MySQL is Oracle, and so on, or DB2 or something like that. And this is the JPA specifications, and then you can use also the JPA and to implement your microservices or your web APIs based on upon this technology. For us, we here in this case we use non-SQL database. You see that there's different non-SQL MongoDB and Cassandra, Redux, Gamefire, Neo4j, Elasticsearch, and Neo4j. Sorry, it has 2 times, and Couchboost. So for this case, we try to implement the RESTful based on. So this is our prototypical domain object definition and domain models. I already said that our big application has in total 24 or up to 50 domain classes, and this is based on these prototypical models. So you see there's the road networks, and then there's access roads, and then there's the plots informations and building information. The building has the floors, and floor has the unit information. For this monolithic application is little bit segregated. I mean, the plot is one unit of applications, one module of application, and buildings one module applications, and then there's a floor one module of application, and then the unit is one module application. This all the modules has also linked to the documentations and reporting and billing and payment modules with that one. So that's why you say that there is only four block of functionalities, but there is an interrelated sub application. It means sub functionalities like billing, payment, and invoicing and reporting, this type of stuff. And that's why we try to make only the plot part, and with the plot informations, and then plus their supporting modules like payment, documents, billing, and invoices. That's why this is our relative domain models to implement the microservices, and then you get the idea what is we are thinking, what is the microservice, how it has to be done, this one. So this is the relative data and dataset requirement for the microservices. You see the detail about the plot and plot information, plot authorization information, billing information, ownership information, payment informations, and also the plot info utility informations. Utility means the whole in the whole utilities means the electricity, gas, roads, and then and internet, and this type of because every plot need to the utility connected, and the billing information means if the plot has to be paid their taxes or incomes, and authorization means who will authorize your plot information, the administrative process, and payment informations, you have to be paid the money for the governments to your plot, and every year, so what depending on the laws of the governments. And you see the only plot, one plot has many buildings. So that means when we build a microservice for the plot and plot related informations, and that means we have to be linked somehow with the billing informations. If we blocked it, like we make another microservice, then we have this billing related information. That means we need to detail about the billing information and its related informations as another microservice. So for here we just try to build a microservice for plot and plot related informations. So here's your maps, because you need the maps to locate or to saw your plots informations, and inside the plots where is building located, you have to be find geographically, and somehow and later maybe you needed 3D models for this the plot and buildings as a simulator models. So you see the maps, and then there's the address location and geolocation information, and this is the data coming from the OpenStreetMap and some part of the Google Maps. So in our web applications, in the screencast number 27, you see the detail about that one. Please go there and saw what is background this application. And the registration, that's one of the most important part for the segregation of microservice. So every microservice has to be handle the logging process or logging steps or registration process. That's what that means. When you make a microservice for the plot and plot information, you need all of them at this these models. And when you're building the building's informations, and you need to steal this information, because the application is a microservice, so every department can control their own applications. And after that, if you need a centralized application, then you can merge it for all the plot related information, microservice or application, and building related a microservice application, even though utility in flow related and unit related microservice application, then they are segregated and they are modularized, and then after that you can merge it all applications. So that's all for the theoretical part. Now we have to start our projects. So in the project developments, you can use different IDEs like Eclipse or MyEclipse, IntelliJ, or STS tools, Spring tool suites. For this case, we have different implementation in the developer. Then some developer use the IntelliJ, some MyEclipse, and some developer using Eclipse in the open source. And for here, I use the STS tool, the Spring tool suites, and this is the good tools, and this is perfectly fit with the Spring technologies, or this is two flexible tools. You get the update for all of the latest dependencies, and it is properly managed. And it's really nowadays a lot of developers are now going to the Spring technology and Spring frameworks. That's all. Let's have a start to generate the projects, or building the project with the Spring IO or Spring initializer. And here you see there's a true building generation to building tools, Maven and Gradle. We use the Maven, and here's your selected language. You can Java, Groovy, and Kathleen, and then there's a version of Groovy. So for us, we use the 15th of the Spring Boot. And we put it here our group names, and here your project name or your Artifactory ID, and this is the Artifactory ID, and you can search it here from here on the search button. So we need the web, we need the REST repositories, and then blah blah blah. Even though we can watch the full version of your projects. So let's say. So you packaging, you have two options of packaging. So where and jar. So this is the jar, means you deploy your application with the embedded Tomcat, and we don't need to maintain the Tomcat. It's embedded Tomcat. So you can select your Java versions, which version you are. For us is a Java version 8. So then after that, you can select from the full version. We need a DevOps tools. Then that means that your code automatically executed, and when you have changed source code, we need to select we try to generate the REST documents, and even though you can write it like the Java documents for your documentations. So here you see that your SQL world and JPA world, so MySQL, Postcase, and blah blah blah. And then here is the non-SQL world. For us is the Elasticsearch as a backend server. So then after that, you can select here we need the actuator. Then this is the DevOps actuator. Then actuator means it generate your respective endpoints. For the endpoints means, your application health conditions, info, and matrices, and that's the type of things is automatically generated. This is really good tools, and this actuator tools, and also the dev tools. This is a really good tools. You can easily integrate, and you get your endpoints information, and you compile your source codes automatically when there is changing something. So let's now we try to generate the projects. Project is generated as a zip file, and you downloaded this zip file to your local systems, and then after that unzipped it and integrate your application to your respective IDE. For as I said, you can use the IntelliJ or MyEclipse or Eclipse, and depending on your development IDE selected. And here we use the Spring tool suites. So the project is done, unzipped it, and I integrate the projects in my IDE. So you see the projects, and this is the project definitions. And now is all the videos that I said, there is a specific module structure. Module structure means specific packaging structure. So I love it to this way. So this is our application main class, and main methods is there and annotated by Spring Boot applications. And this is the models and the repositories and resource surveys and service implementation and utilities. So I will go the detail how is it done. So if I say that the models, so it's a microservice applications. So that means we have in total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 10 domain or objects definitions, and this is the information for the building plot related information and the building related information, and this is the registration process. That means this is the two domain class or objects in maintaining your logging logout mechanism, and then also the registration process. And that means every application has to be maintained this logging process, because the next microservice will be based on the detail about the building information, flow information, and unit informations. Let's go detail about the what's the content these informations. So it's annotated as a Elasticsearch based models implementation. So documents and this index name and this type, and here is our content of the objects of the domains. So here's the primary key, and you see the strings, all the informations, the plot code, plot name, type, number, and the CSS number, MS number. This is specific for each of the governments and the PL or remarks. And this is the information of the where the center location, and also the how the height of the plots from the mean sea level, and this is our pictures. So that means you take the picture from the Google Maps or Yahoo Maps or whatever OpenStreetMap, then put it the picture here, and then you can really find out where is your polar plot is located. And this is the most important part you have to be concentrated here. So this every plot has to be linked or has to be one to many related with the authorization, because every plot has to be authorized by different institute or companies or whatever, what different departments, and that's why I need. And then the plot has the ownership information. That means one plot has multiple ownership information. That means father or mother, and also the son or daughter, and even though in the company to company, the ownership for each plot, and payment informations, and the one to many payment, because the plot has to be, the payment has to be scheduled, like every year has to be paid the taxes or income taxes, and you have to be paid the payment for the utility services. So here the many utilities is linked to the each plot: utility, gas, electricity, internet, and drainage and sewer systems. And here is the billing information. You have to be maintain your billing information from the how many cost, like for the utility cost, and have the tax cost, and then you have to maintain your bank informations. And it's a little bit complex applications. We try to categorize, we try to modularize this application. Here is the building information. As I said, one plot has multiple buildings informations, and then building has to be linked, and then plot has a geographical details. So now we have to go more detail about what's information for the authorization. So authorization means here the all information for authorizations, and his document copy, and then your approval copy, and then standard getter and setters, and that's a primary key, and when did the authorizations, and when they approved it, when you applied it, and when they published this the authorization copy of this each of the plots. And this is the your documentation information, the documents, your index information and type of the index. So, and then let's see what the billing informations is. The billing information when the bill created, who is the authority for the bills, and there's the related information, timestamp informations for the billings. And here's your information about the remarks for the for the billing information. Is a bill paid or non-paid, and then blah blah blah, and how much amount for this, and even though the copy of the bills. And here is the ownership information for the plots, because it's one to many related, and then there is the ID related, maybe the ownership ID, maybe the national IDs or passport IDs or passport number, that's, and so on and so forth. And when the ownership owner is linked or linked with this plot, and where is the is it last time what's the modified means when the change the ownership from one owner to another owner, or one owner to many owners, and that's why we need this information when the ownership changes. And the payment information is like this way, and when the payment created, and documents, and total payments, and paid and unpaid, and this type of information containing this domain class. And then here is the utility informations. I already said utility means electricity, gas, and internet, or Swedish, or whatever it is, the new utilities for the plots. And the plot means after that the plot has the buildings, then this utility has to be linked with the buildings, and building has a multiple floors, and each floor has to be linked with the utilities, and then each floor has multiple units of units, and then this is the linked with all of them, the module services. So here's the registration class, and then you see the registration, the registration user, the username, password, and then his role of the registration. So each registered user has multiple roles, and you can put it the role. So the role has containing the role ID and the role name and role type, and then when the role created, that means when the user is created for with this specific role. Maybe user is created this year, and next year he has to change the role, then we have to change it here, the role, the registration process. So this is, you saw the our all the domain definition, and the domain has containing the all related. Our domain definition is done, and then now let's see our implementations for the service definitions, the REST service definitions. So here's the modules for the REST service definitions, and this is the repositories for all of them. So you see that our primary repositories, and this is the repository default, the Elasticsearch repository, and this is plot information. That means the plot has multiple linked with the ownership, authentication, billing, payment, and blah blah blah, so on and so forth. This is the domain REST repository REST resource definitions. So this the annotation did automatically your code operations. We do not need to do nothing here. So here is the was the default, again the default definitions, and then this is the role definitions, and the locations for geolocation for definitions of our old implementations. Sorry. And we define your own interface definition. You can do your own CRUD operations, but to define your service and implement your service, and use some other repository concept or repositories for that one. So I try to put it in one example, or to get it clearly to get you, and to get a clear definition how we can do you yourself, not using the default one. So this is so here's the implementation for your own REST repository, and you see our plot repository, and then you implement your CRUD operations, and that's all, and it works perfect. If for this case you have a really more control your developments, you can process your developments by some utility function for logging functions. You can control it your time instant, and whatever it is. There's more control is your side. The developer can do it. So they see the implementation look like this. So we use the plot repository as it is, as the repository that we have it in the systems, and then you control your application. If it's null, then do the return. Is not null, then return the list. If it's null, then return don't throw the null point exception through the objects of the plot informations. So this is one of the implementations, your code operation. This is the professional, the standard way has to be maintained, because if you are working in the company and company needs some such a structure, the clean code or clean development code for this way. So that's why I put it every time. This is the specific process or specific packaging style or packaging process to implement some such a features everywhere. This is a professional way. So that means modules, repository, resource, service, and service information utilities. So what's the resource? Resource is your endpoints definitions. This is the most important endpoint. So we call our services, our interfaces, and then we set our request mappings, and then blah blah blah, so on and so forth. And that's the more important, the more control part. So that means You define your interfaces for your CRUD operations or whatever it is or more, or you need a spatial search, then you can put it here. That you implement, you define your interface and implement here, and you have more control with your implementations. So resource means, I like a lot of people asking me why I call it like resource, but it's look like resource, but you can define it like as a controller. So as a controller packet like so UVSoftGroup, so your application name, and then you can say controller and then put it your all controller, then depending on your decision, but I found it really good here this way. So here you can put it your utility function if you need more control, your HTTP control or HTTP codes, and then here you can put it here your status and message and code, and you can integrate what you would like to do. Now, you can integrate the utility classes in here. So it's hard to maintain your utilities in the if you are define your repositories as a default repositories like here, like your this is the default repository. So here is you have no more control, but the implementation is really flexible and really good implementation. You don't no to nothing. You just code it, annotated it, and you define your resource and you define your path, and that's all finished. Everything is done by the frameworks, by these annotations, and that's all. So here is the most important. Here is we need more concentration about that one. So I say this is the really externally configurable application. So there's a lot of viewers and subscribers asking me give them really this possibility, and they have really good comments from them. Because it's really dynamically configure. You can put it your application where you'd like to do. Just you need to change some keys, values, and your properties. So if you close look at these two to 4 environments. So later, so you see our resource definition here is our standard, the default one. You see our application port started this number, and this is a local host deployment. And then if you have it in the data center or deployment in Bangladesh or Germany or USA, then you can has to change your machine number. And this is the really most important one, which environment you try to deploy your application, and this is the your cluster names, and this is the properties has to be override from the externally configured file. I will show you how it's done by the deployment process. So is it localhost and enable this ones. So here is the same thing, just we need to override sorry, override from the externally. So it's a productions environments, and then this is just a really close look at the application minus and dev, pro, QA, rel, and test environments. So this the three configuration properties file is controlled by the externally, and which environment we try to deploy our applications. So and that's really important where, and because we are now living in the DevOps culture. So as a developer, you have to maintain all of them. If you are in a small company, like company size like 50, but if you are a big company, they have it, the DevOps engineers. So just your job to build the applications and give it to your jar files or Word file, and they will deploy the applications. But if you are a full stack developer, then you are responsible to deploy your application from development to test or QA or production, whatever it is. You have to maintain those applications. That's why this is too important to maintain your deployment process, and also your deployment, your applications, and also your deployment or migrate your databases, and depending which database you are using. So I already generated the applications and the first version of the deployment. Just you go there, because we are using Maven and run it as a Maven install, and it's generated your jar files. This is embedded Tomcat with that one. So I already generated these applications, and here is you see our jar files. So this is the jar files. You just copied it to the any specific server or any container, in any server or any local files, and give it to them the possibility for the installations, and I will show you how I write the script for this installation process. So you saw that this is our jar file. That's what we generated it in from the applications, and this is our environment setup, and this is the service started applications. The application will be started. Let's see how is it information is containing, how is it coded, the script. So you see there is the applications is now okay. We have environments, we have your Java location path. If the environment variable is not set, then you can just simply change it. And if you have a different, that's the cool things. That's the cool things you say. That's the cool, really cool things. If you have a different Java versions and your application is portable to Java different versions, not lower than that one at Java 8, but upper version, you can just simply change it here, and your application should automatically deploy your application. So you can select your port number and you select machine number, then your version, your application, and your version number. So this is our jar file that we have in the application deployment directory. So here is the most important part. That's why I said this is a profile, the resource dot application. Here is our environment definition is done, and then you see that your cluster nodes, and then there's our cluster names, and then the enable true, false, and true information. And here is your most important settings. So we called our environmental settings and set the path variables for the Java home, and then your jar file information is important. That this is our application is here. So here is the variables, we set it here, and there's the profiles. So we run the application in the development environment. So you have to need to change it here. If you are in the productions, just prog, and then if you are other environments, rel or whatever it is, then just you change it here, and you have to change your port number and your machine location or machine path number, and then you have to change your cluster names, and that's all, and then it works automatically. And here is our the calling, and you see our definition is done. So then now, before running the application, because you have to run your Elasticsearch server, so you have to run your Elasticsearch very fast after running, before running the Elastic. So Elasticsearch has to be run first. So it's, and then after that you have to run your applications to the this is you see that your definition is there and your setup is there, their jar file is there. Then just you need to run a start service, and that's all. Then the application has to be started. So let's see, our Elasticsearch has to be started, and then you have to application. It has to be run by your applications, and that has to be. And now we try to test our application with Google Postmans. You can use different IDE like REST clients IDE or SOAP UI for testing your APIs. I will give you more detail about the Postman testing, how we did it for this application for the testings. So you saw the application is running, and then this is your port, and then Tomcat, and the user port number is it here. So initializer port 1035, and this is your development environments, and the application is successfully deployed to the development environments. And the same things you need to deploy you need to change your machine port number, machine number, and your cluster name. So this application is successfully deployed and successfully run in the port number 1035. So let's have it start with the testing in Postman. So you saw our Postman setup is there. So I have a lot of projects to test it in Postman. You see a lot of projects where our REST projects. So you have see our lot of test cases is there. So 21 request for the different URL and different endpoints. I will show you how some part of the application how is done, the major part of the plot CRUD operation for the applications. then that's why we said it, here our application is deployed, and we can check up because we application is running, we can send up and then see the application status of the application. So the application is up, the tomcat is up. So then we have a different post, then get post, and then let's have insert one application. You see our URL, plot info, and your informations, and then let's see we need to define here our applications, our objects. So we said the plot informations in here, and then there is a plot has many building informations. There is only only one building information is stored, and the plot has a multiple geolocations, and geolocation 1 and latitude, longitude, and then some remarks. And here is the geolocation 2 and geolocation 4. That means in the plot has multiple 4 buildings. I think so. So 1, 2, 3 buildings, 4 buildings, and he has a central coordinate for each of the buildings. And there is a plot one to many authentication informations, and on the content of the authentication information, and then ownership informations is only mapped, and then you can put it here in the payment informations and the utility informations for the plot, and the billing information for the plot. Just I put it here to one screen, one the test cases. So there's so let's have it start to put and then send it to the request. And this is the application, the record inserted properly. So as you see the status 201 created, and your objects, and here is your IDE for the primary key for the insert process, and then after that you can search for the whole record set for the for your inserted records. We did it previously, record more, and you can see the information is recorded. So a total records 5. We already did it, and hits and totals and information for the plot information is here, and the building information is here, and then you have location utility information is here, and then authentications, ownerships, payments, utility, and then and so on and so forth for the information. So here's 5 records, and each of the records is there. So this is really this tool is really flexible and really important tools for the REST API testing or RESTful web service testing. Even though you can, SOAP UI is a good tools also, depending on your company requirements, or depending your requirements what is good for you. So here's the one of record is get specific record to be up to be get. Yes, the record is there. So 103. So it's get the specific information. So get by ID, and then that's all. That's so on and so forth. So put, and you change the some information 130, and maybe just change it to your code. Just put it here, code blah blah blah, and then maybe change something. And then you put it your push request, and it works automatically. It's okay. The put is done properly. You see that your update is done. So you get your update, and then you can change it whatever you'd like to do. So put is done, and you can post, and you can delete some of the informations, maybe delete, and as you delete operations, and then you said just like you delete the 13 number 110, and it's done. So you can do too many tested, too many tests, all of the domain classes. So we did a lot of things here. So for the registrations and user role and individual health conditions, and here the lot. So here you see the lot of tests. Or you can, even though you can build your test with a and generate your test script and send it to the other test department, and they can run it depending on the environments. So we did our testing here, and then you export it, the test cases to the other departments, like QA department or test department or other developer. Just you exported this application, the test cases, and they will run the test cases, and they will change the applications. That I said they will change this part of the applications, and then that's all. That's enough for them to deploy the application into different environments, and then test, run the same test that you have in development environments, and it should automatically go the test cases. So do more tests with that one. We have different videos for detail about the Postman, how can you set up the global variables, and it's, I think so, just go the my channel, and there is a detailed overview how can you integrate, or how can you set your global environmental variables. Then your application, your test cases can run in different environments and with different URLs. So here is one of the setups for other projects, and this is dev environments is running dev copy, and this is productions and the QA rel, and then so on so forth. That means that if you plugged it like this way, so if I go there, they say the application URL is there, and this is the one of the examples. So you just you call it these variables, and you set up your URL and use the variables, and you export these test cases to the other environments. So this is the global, how can you set up the global variable for in Postman, and after that you run your test in different environments. That's all. That's the testing is done. So what we did, we get our theoretical background, why we put it the microservice applications, and we implement, we generate our project with Spring IO or Spring Initializer, and then and we just as a zip file, we download it and unzipped it and integrate the project into our respective IDE, and we define our projects, we define our modules, and we did our implementations, and the most important, we set up our our environments, our properties files, and then we wrote it our environmental setup, and we run our applications to the externally deployable applications. And that's really important, and that's really important for any scale of development, or any automatic deployment process. So now we did our all things. Then thank you all. If you have any questions, leave a comment below. I will try to answer. And do not forget to subscribe my channel, and to get a new upcoming videos, just push the bell button, and you will get automatically our new screencast and our updates from our channels. And have a good day, and thank you. See you later. Bye.